All right, we're gonna finish up chapter 3, section 1. Here's a review of what we did last time. What'd you get for the first one? All right, let's see. So for the first one, we have square root of -8, 3 square root of -18 minus 3i. Because those are negatives inside square roots, what do we do with them?
Negative.
What does it? Take out the negative, we put I in front. Okay. Okay. So we have I radical 8, 3i radical 18 minus 3i. So that's the first thing. We got rid of the negatives inside there. The next thing we do is simplify those. 8 is made up of 2 times 2 times 2. Eighteen is made up of 2 times 9. 9 is made up of 3 times 3. So it's 2 times 3 times 3. And then bring down the negative 3i. So far, so good? Now, since it's a square root, once we see a pair of any numbers, that comes out. Since these two are a pair, they come out, leaving the last one inside there. We have a pair of 3s in the second one, so that comes out in front. And that 2 stays inside there. So far we have 2i radical 2. 3 times 3 is 9i radical 2. Are we done? ¿Por qué no? We can combine like terms. This is a radical 2 and radical 2. 2i plus 9i is 11i radical 2 minus 3i. That's as far as we can go. That's the first one. When we say like terms, they both have to have an I and they both have to have a radical 2 in order to be like terms. They both have an I, so they're both imaginary, and the radical 2 is the common factor. Can we combine 11 minus 3i? No, because they don't have a radical 2. Okay, the next one. I threw this one in there is because that's what it's plus over minus. This, for some reason, is one of the hardest problems the students have on their homeworks. What's the rule about division with imaginaries? You cannot have an I on the bottom. So we have to get rid of it. How? Because it's a binomial, we multiply by the conjugate. If it was a monomial with an I on the bottom, then we just multiply I over I. But since that's an equation, so what's the conjugate here? 1 plus I. You only look at what's on the bottom. Don't care about the top. It's going to fix out at the end. Can you tell me which one be on the bottom? No. Okay, let's work it out. So on the top, 1 times 1 is 1. Positive times positive is positive. 1 times I is I. On the next one, positive, positive is a positive. I times 1 is I. Positive and positive. I times I is I squared. That's the top. Now the bottom. 1 times 1 is 1. 1 times positive I is positive I. Negative times positive is negative. I times 1 is I. Negative times positive is negative. I times I is I squared. Whenever you get rid of parentheses, combine like terms. So on top, we have 1. I plus I is 2I. What do we do with the I squared? Yeah, it turns into a -1. On the bottom, we have 1. Positive and negative I cancel. This becomes a negative, so it changes that sign, so it becomes a +1. One minus one cancel, so we have 2I on top. 1 plus 1 is 2. The 2's cancel, so our answer is I. Again, that's just it. Once you leave this room, a lot of times you'll forget everything. So that's why as soon as you go home, start doing your homework, or as soon as you leave the class, look at your notes. So we have one more topic to discuss in this section. The rule is this. I cannot have an exponent. So if your answer has an I by itself or with a number in front of it, it's okay. It doesn't have an exponent. But we also found out that I squared becomes what? -1. So the question here would be, what would that be? Let's look at that. Let's look at the pattern here. Okay, this next part's going to take some time to build it out. Bear with me. I'm going to do it 8 times. So we know the first one is I. That's I to the first. We know that I equals I. We know that I squared is -1. I cubed. I cubed is I times I squared. Because if you add the exponents, you get 3. So we have I squared is -1, so that becomes -I. What we're doing here is called inductive reasoning. We're using the previous line to prove the next. So I to the fourth would be I times I third. So we know we have I. What is I to the third? Negative I. So I times negative I is negative I squared. I squared is negative 1. So the answer is 1. Let's take the next one. If I'm going too fast, please stop me. Throw me a $10 bill or something. I times I to the fourth. So I to the fourth is 1. So I times 1 is I. I to the sixth is I times I to the fifth. I to the fifth is what? I. So we have I times I is I squared, which becomes negative 1. I to the seventh is I times I to the sixth. I to the sixth is negative 1 times I is negative I. I to the eighth is I times I to the seventh. I to the seventh is negative I. So we have negative I squared. I squared is a negative 1. So it becomes a positive 1. So far, so good. We see there's a pattern. We start off with I equals I. I squared equals negative 1. I cubed equals negative I. I fourth is 1. I fifth is I. I to the sixth is negative 1. I to the seventh is negative I. And I to the eighth is I. So we see a pattern forming. We see a pattern forming in groups of 4. And if you think about it, it has a pattern that if you won a game or if you won a race that you didn't think you were going to win, what would you yell? I won, I won, I won, I won. And the middle two are negative. That's the easiest way to memorize it. I won, I won. And the middle two are negative. Now, why is that important? Because these patterns are going to help us find this. So let's look how this would work. We're trying to find I to the 45th. Here is the pattern. This is your exponent. So we have I to the first, which is I to the second, which is negative 1, I to the third is negative I. I to the fourth is positive 1. Since they happen in groups of 4, if we divided the exponent, by 4, we only have to find the remainder to determine what our answer is going to be. Because the answer can either be I, negative 1, negative I, or 1. So 4 goes into 4 one time. 4 goes into 5 one time. And that's our remainder. Okay, so that's our remainder. Now we look over here. If the remainder is 1, the answer is I. If the remainder is 2, the answer is negative 1. If the remainder is 3, it's negative I. And if there's no remainder, it's 1. And we can call that the solution. So what would this one be? Yeah, the answer would be I. Go to your example sheet. Because we didn't do example 4 last time. Find I to the power 37, I to the power 58, I to the power 75, and D, I to the power 80. The first one, we take 4, goes into 37. Does 4 go into 37? How many times? 9. 9 times 4 is 36. Remainder is 1. If the remainder is 1, solution is I. So this one becomes I. The second one, 4 goes into 5 once. 4 goes into 18 4 times, because 4 times 4 is 16. The remainder is 2, which makes it, the remainder 2 means the answer is negative 1. Four goes into 75. 4 goes into 7 one time. 4 goes into 35. 4 times 9 is 36. That's too big. So 4 times 8 is 32. The remainder is 3. So the answer is negative I. Can we guess what the last one's going to be? 4 goes into 80. 4 goes into 8 twice. Remainder is 0. The answer is 1. Pretty straightforward. So whenever you have higher polynomials than that, then just use that divided by 4 and you're done. Okay, that does it for chapter 3, section 1.